Hey math kids, today we're going to talk about derivatives of log functions. And so if we have y equals natural log of x, then dy dx is equal to 1 over x for x is greater than 0. Okay, so if we have y is equal to natural log of 1 minus 3x, and y is equal to x cubed natural log of x. Okay, so what we're going to do, we're going to use this relationship right here. And so we just do 1 over the inside. So with natural log, that's going to be our first thing that we do on all of them. And then we need to multiply by the derivative of the inside because of the chain rule. And so we end up getting that for our dy dx. Okay, on this one, we're going to have to do a product rule. So if I call this u of x, this is v of x. Actually, sometimes I like to just say like a, b, and then a prime is going to be 3x squared, b prime is going to be 1 over x. So with the product rule, we just write one of them, and then do the derivative of the other one, and then we write the other one times the derivative of the one we haven't done. Okay, we could simplify this a little bit, because that's going to be x cubed over x, which would simplify just to x squared, so all of that, and then 3x squared natural log x. This one we're going to want to keep in mind some of our log rules. So we have natural log of x e to the negative x. So before we take the derivative, we're going to rewrite that as natural log of x plus natural log of e to the negative x. This actually simplifies because those cancel, because natural log and e are inverses of each other. And so we end up with that. Now we can take the derivative. Derivative of natural log of x is 1 over x, and the derivative of negative x is negative 1. Alright, next one looks like this. So once again, we're not going to start with our derivative. We're going to start with our log rules. So natural log x squared minus natural log x plus 2 x minus 3. We can use our log rules because division is subtraction. Now if we break this one up, we can write it as natural log of x plus 2 plus natural log of x minus 3. And if we just distribute that negative, we get natural log x squared minus natural log x plus 2 minus natural log x minus 3. And now we're going to take the derivative. So we get 1 over x squared, but then times it by the derivative of the inside. So that's just for that one. And then this is going to be minus 1 over x plus 2 times the derivative of the inside, which is just 1, so we don't need to do that, minus 1 over x minus 3 times by the derivative of the inside, which is just 1, doesn't change it. The stuff written in purple is going to become 2x over x squared. If we reduce those x's, we're going to get 2 over x, and so I can replace that with 2 over x minus 1 over x plus 2 minus 1 over x minus 3. Okay. Alright, if if we have y equals log base a of x, then dy dx is equal to 1 over x natural log a. So if we have y equals log base 5x, or if we have log base 3 of x squared minus x, we can use this info. So using this, we're just going to take what's inside and put it right there. So 1 over x, and then we do natural log of the original base. That's our dy dx. Okay, over here, we'll use the same thing. The inside goes out front. We do natural log of the original base, which is 3. And then we need to multiply the entire thing by the derivative of the inside. So that's going to be 2x minus 1. And to simplify that, this will just end up going on top, because we'll just multiply those fractions together. 2x minus 1 over x squared minus x times natural log 3. That's it for this video. If you need additional help, please come to MathLab. Until then, calculator.